The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. Welcome to the Scrum.org Global Webcast series, an ongoing public discourse on Agile, Scrum, and professional software development. My name is Daniel Rakowski from Scrum.org, and I'll be the moderator for today's session. The series is presented by Scrum.org, dedicated to improving the profession of software development through our professional Scrum training courses offered worldwide and our assessments, and also our Agile and Scrum resources, which you can find at scrum.org. I just want to go through some quick guidelines before we get started here. This webcast will be recorded in its entirety, and your microphones will be on mute for the time being, but if you have any questions or comments, you can post those in your chat window feature on your GoToMeeting window, and I will be responsible for making sure that your questions are addressed by our speaker today. And if you have any audio-visual connectivity issues, you can let me know through the chat window, and I'll help you get those resolved as soon as I can. Now for today's webcast, we have with us Chad Albrecht. And Chad, over the last 20 years, has been an executive, a consultant, a developer, and an Agile coach and trainer. He's really done it all. And today, Chad is going to be delivering his presentation on Agile economics, the dollars and cents of Scrum. He'll be addressing some of those bullet points that you can see to the right of the screen there, and a lot more, but really this presentation is about Agile and how it makes sense financially. And Chad is going to be addressing those issues for you today. Now, without further ado, let's get right to it, and I'll just make Chad here the presenter so you can see his screen. And Chad, the stage is yours. Welcome.
Thank you, Daniel. Hello, everybody. Looks like we've got a good crowd of people here today. Yeah, so dollars and cents of Scrum. When I'm talking about Agile or doing one of my courses or workshops, I often get asked by executives, VPs, CFOs about the financial side of things. Like how does this work economically? What are the cost structures? How is this all going to fit into my organization? Because everybody's concerned from a business standpoint about the money side of it, and we often don't talk about the dollars that make Scrum work, the dollars that make Agile work, and the models that go with it. So, over the last 10 or 15 years, I've put together some ideas, collected some different models, talked and studied a lot about economics, looked at different finance structures. And I've compiled it here for you today. So we're not going to get into a ton of equations and economic models, but what I'm going to do is I'm going to present some basics, and we're going to do a case study at the end. So start things off here. So who am I? I'm the VP of Center's Agile practice. Been in the business for 20 years, like Daniel said. I've led numerous waterfall to Agile transitions. I started working with Agile and Scrum in the late 90s, so really been doing it for about 15 years, and seen it from both sides, right? I've seen it from many different sides. Seen it on a team, as an executive running a large number of teams, and then as a coach and consultant helping others actually move through this. So throughout the day today, throughout this presentation, I'll be taking questions. I'll pause if you want to put some questions in the question window, in the chat window there. I'll pause to answer those questions. Who is Center? We're a Midwest-based consulting organization. We focus on Agile and ALM, mobile and cloud spaces. 2011 Partner of the Year finalist with Microsoft in the ALM Gold competency. We also are an Azure Circle partner and a Cloud Accelerate partner. In our mobile space, we do a ton of iOS and iPad development, as well as Android and Windows Phone. We're a Scrum.org partner. We have a number of professional Scrum trainers on staff, and we also have a general consulting practice that helps organizations do just general software development. So that's who we are. So today, I'm going to touch on what economics is, what finance is, how the two are similar, how they relate, simple one-slide discussions. Then we're going to touch very high level on Agile and Scrum. My guess is all of you are here because you know a little bit about Agile and you want to understand financially why they're relevant. So we touch briefly on that and then dive right into software economics. What are some of the things that that make people buy software? What are some of the things that drive their choices? Which then leads us to human factors and fallacies. We have a lot of belief in this industry about certain things, and we're going to talk about certain statements that are made regularly and why they're actually false. Bringing all of that together, we're going to talk about the finance or the financial and risk models. So kind of within the organization itself, when we use Agile versus using more traditional techniques, how do those two things look, and how we actually compare those using dollars. We're going to wrap that all up at the end of the day or end of the presentation and talk about a case study. I'm actually going to try to compare a traditional model, building a product, versus an agile product, where we're actually going to use the same numbers, same team, and I'm going to walk you through start to finish how that team might perform better in an agile setting, and what the actual finance actually looks like around that. So starting with economics. Economics is really about why people make buying choices. It's a social science. It touches a lot on psychology. There's a concept in economics of this homo economicus, of this person, this rational agent that buys things, and buying decisions are rational. But what economists also struggle with is that there's a lot of irrational choices that are made in a large economy. And that's part of the reason that this is constantly evolving. But we do understand quite a bit about when somebody prefers something, their buying choices will be driven in a certain direction. And we're going to talk primarily about those preferences today and how we actually look at those and why we're challenged with that in the software development industry. There's a number of other things that are covered in economics as well that are relevant to today. We're going to talk about things like opportunity cost, production and consumption, efficiency and commoditization. So as we actually figure out how to build something, it becomes a commodity, and then we actually can touch on things like globalization and how that's impacting the things that we do every day. So things that are relevant to economics and to this presentation, but we're not going to cover, but I recommend you go do a little reading on, is game theory, uncertainty, and by uncertainty I'm going to talk a little bit about estimation, but there's a ton of depth in uncertainty here. Great materials out there, and then macroeconomics. So things like GDP and corporate structures and things like that, we're not going to cover that. So we're basically going to just cover the homo economicus, or why we actually buy, why we prefer to buy one thing over another. Finance. Finance is related to economics. Finance is really how we actually are able to buy things, both from a personal finance and a corporate finance standpoint. We're going to deal with things like money management, so the price of things, the costs related to them, return on investment, payback period, all of those things I list there, as well as assets, liabilities, capital, and risk. So we're going to talk about risk a little bit later. Investments and budgeting, it directly interacts with economics. So economics seeks to actually understand why we buy things. Finance, you can think about it as the models used to actually buy those things. So how do we actually finance those activities? Very interrelated. Any questions so far by anybody? I'm not seeing anything. David?
So it looks like we have
Daniel?
one question that came through. Can we show the slides at viewer window? Okay, so it looks like you're only seeing the initial screen with information about the organizer and presenter. That is odd. Let's
We
see.
have some technical difficulty questions, but we don't have any content questions, Chad, so go ahead.
Okay. Excellent. So a quick recap here of how people develop software in the industry. I'm just going to touch real briefly on these three. I think they're a good breakdown of a lot of the software development methodologies that people use out there. Traditional is typically a gated process, moves forward in stages. We start with analysis and making sure we actually want to build a project, maybe a little bit of budgeting and discussion about design. Finally, we go to implementation, then we go to quality or testing phase, and finally roll it to production. Going backwards, very painful. I'm sure you're all familiar with traditional or waterfall techniques. The next is iterative. So what we do is we say, all right, traditional, we struggle with traditional, let's make those cycles just shorter. Iterative is based on traditional. Typically the scope of each iteration, each segment of time is smaller, but we tend to follow the same steps. So maybe we do an 8-week iteration, but we go through that design, implementation, testing, and rollout within that iteration. The last is Agile, and that's what we're going to talk about and kind of compare to traditional today. It's built off iterative. We stress smaller cycles to get constant feedback. We focus on collaboration and team commitment to quality. And then finally, transparency with the business and from the business to the team, inspection of the product, inspection of the process, inspection of what we're doing on a day-to-day is key, as well as adaptation. So if what we're doing is not working, let's actually make a change. If the process that we're using isn't working, let's make a change. And those are really the three buckets of process that we see out there. So again, we're going to talk about agility today, and I thought it was worth covering the word Agile and Scrum itself. I often hear people say, people ask, are you doing Agile or are you doing Scrum? And it's important to note that Agile is an umbrella. Agile means lots of different techniques. All of these things could be considered Agile techniques. Scrum is a framework, i.e. a way to actually describe how we move from day to day, different roles and artifacts. It doesn't describe or doesn't provide a recipe of how we do our work. XP, on the other hand, does provide some of those recipes, and it's considered more of a methodology. Lean is in that as well, and it talks about things like elimination of waste, and it has inspection pieces built in as well, and there's a handful of other things. So all the way, DSDM, AUP, tons of other things under this umbrella. So when we talk about Agile, we're really talking about, if I go back a slide, this iterative, collaborative, transparent way of building software. So that's how we're going to talk about it today. If we look specifically at Scrum and the pieces that are necessary in Scrum, we're going to start with the roles. So we have a product owner who has the vision of what needs to be built, the direction it's going, and the order that things should be built in. We have a Scrum Master who's making sure that the overall framework of Scrum is being followed. And then we have a cross-functional development team that includes everybody necessary to actually build a working increment of software. And these three roles work together to actually build the software product that we desire. So to start with, the product owner is working with stakeholders, working with the market, working with the organization to build something called a product backlog. And that product backlog is simply an ordered list of features, desirements, non-functional requirements that need to be built in order for the product to be successful. On day one of kicking off the project, the whole team, the Scrum Master, the product owner, development team, get together and they do a sprint planning meeting. In that sprint planning meeting, they extract a number of items off the product backlog, and they say we're going to build this for the sprint. They may do some task breakdown and other activities that actually help ensure that they understand how many of the things off the product backlog can be done. Now, we're not going to get into the specifics of how that's done. We have courses, Scrum.org has courses that we offer, as well as some workshops that help you understand how to do this activity. Just understand that for sprint planning, we extract a number of features off the backlog that are going to be done in a iteration. In Scrum, that iteration is called sprint, 1 to 4 weeks in time. Once a day, we do a daily Scrum where we actually look at how we're doing to actually reach our goals. And the goal being delivering software at the end of the sprint. 15 minutes in duration. Typical questions that are asked during that meeting is, what did you do yesterday? What are you doing today? And what things are in your way? These are really primer questions to have the team get an understanding of, are we on track to delivering that working software by the end of this 1 to 4 weeks. Testing, very, very central to using Scrum within software development. We have to test on a regular basis, almost hourly, to actually be able to deliver working software at the end of every sprint. Product backlog grooming, making sure that we as a team understand what's coming. Another very, very important piece to making Scrum work. I don't want to get into the next sprint planning meeting and have to see everything fresh, see everything that's coming for the next sprint, and have to ask tons of questions and do tons of research on things in that sprint planning meeting. So we spend about 10% of the sprint time actually making sure that we understand what's coming. There may be a little bit of deviation at the end of, towards the end of the sprint that we're not aware of. That's covered in the next sprint planning meeting. It's simply a way to actually manage that backlog and manage the things that are coming up on us. At the end of the sprint, we've done all these things, we've performed all these activities, we've collaborated with the team, we've talked to the product owner about what we're building. We deliver a working increment of software in the sprint review. And in that sprint review, the stakeholders get a chance to actually inspect the software, ask questions about it. We can validate whether or not we've built the right thing. It's a working session for us to understand, are we on track with building this software in the right way? Before I move on, the last thing that happens in a sprint is the team gets together and says, how well did we do this sprint? What things could we do better? What things should we keep doing the same? It's really the moment in the sprint where we formalize continuous improvement. And we actually talk about things that might possibly go on the backlog for the next sprint, things that we want to formally do in the next sprint to actually improve. So it's our improvement point. And for those of you that have been studying Agile or know a lot about some of the terminology out there, this is our Kaizen event. This is the moment where we actually practice continuous improvement. After the sprint is over and we've shown the stakeholders are working software, there's still things that are happening behind the scenes. We have the product owner continuing to talk with stakeholders providing feedback to the product owner based on this working software that was released last sprint, and the product backlog continues to evolve and change. That's why we need product backlog grooming. So this is an example of an Agile framework that's used today that we know is successful and working for many organizations out here. And you can refer back to this or come back to this in your mind as we move forward today when we talk about iterations and quality and stuff. This is an example of how that works. Any other questions out there, Daniel? I don't see anything.
Looks like there are no questions at the moment.
Okay.
So you can continue.
All right. So in economics, we measure preferences with something called utility. And you can think about it as a way of examining as a line how much we prefer something over time, how much we prefer something in quantity, i.e., if I order an ice cream cone from Dairy Queen and I have one of them, I have a preference for that a lot on that first one. My second one, it's the same product. I might not have as much preference to consume a second ice cream cone. How about the sixth one? So we usually value smaller quantities with certain things like ice cream or sweets. The first one has more utility than the last one. So you can think of that as a downward sloping utility, right? We prefer the first one the most. Additionally, how much are we willing to pay for that ice cream cone if there are tons of choices, if there's a lot of different ice cream shops, versus if there was only one ice cream shop in a 5-state area, how much would we be willing to pay for that ice cream? Probably a little bit more. And finally, how does time impact our preferences? The example that I like to use for this one is, you know, a Betamax player. Over time, technology changes, evolves. Our preference for older technology, older things, time impacts our ability or our preference for certain things. All these things come together and actually can be measured as utility. It's kind of hard to see my slides here with this in the way. Hold on just a second. All right. So to simplify that, utility decreases or our preference decreases based on consumption or time. We prefer new features to old features. And then from a software standpoint, the longer you wait, you'll often find that a market or that stakeholders will find alternate ways to solve problems in lieu of software. The example that I often give here is if you're developing a piece of software to interact with the database, but Excel can already interact with the database, and it's going to take a year to get this piece of software written, somebody that can use Excel to interact with that database and do their job, the better and more efficient they get at using Excel to interact with that database, the less they're actually going to value the software that you're building. So that's going to be a problem, and we'll talk about that here shortly. Finally, many choices push prices down. So the more options we get, the less we're willing to pay for something. If you think about cut and paste, when the first cut and paste applications came out with Apple, people were willing to spend a lot more with that because that was a very useful feature in a piece of software. Today, we just have come to expect that to be in all software, every application and platform to have cut and paste. So we value that less. Lots of different utility curves. And I'm just showing ones versus time here, not ones actually versus quantity. But the point here is that depending upon what they are, we can have different slopes and different curve values for utility. The first one there on the left would just be something that's released and it just gets less and less valuable to the consumer. The middle one there would be there's a lot of hype that's coming. Think of an iPod being released. People are willing to pay more and more and more for that until the market starts getting saturated and it starts becoming easier and easier and easier to get an iPod or an iPhone 4S or whatever. And then finally you have some devaluing of that commodity. And the last one would be a very peaky type of utility or peaky type of preference where there's a run on something, people very quickly want to spend a lot of money on it, but as people realize it doesn't really do what they expect it to, it devalues very, very quickly and typically, flatlines or goes to zero. So a way to simplify this discussion and think about this in some of the graphs that we're going to talk about and some of the case studies that we're going to talk about is that software depreciates. We're always fighting time. From the moment somebody has an idea, that idea or that feature in software continues to devalue. And while there are cases where a feature here or there is going to increase in value as we hype it or as we talk about it, think of the iPod example on the previous slide where there's some marketing and advertising that happens ahead of it. Overall, value over time is a downward sloping line. And again, this is going to be an important point as we move forward and talk about Agile versus traditional techniques. So remember, depreciation. We're always depreciating software and features. Any questions on that? Anybody have any feedback on that?
Again, if you guys have any questions, you can just post those in the chat window there, but it looks like there are none at this time.
Okay, thank you. Finally, back to that Homo economicus, we have to bring in some of the human factors as it relates to preference. All these factors add to the depreciation of requirements, features, and software itself. One of the questions that I ask is, what did you specify the last time, or what did you specify for dinner the last time you were out? And the point here is we forget what we asked for. We forget what we ordered. And the same is true for stakeholders that ask for certain features. Now, we can write these things down, but people's idea of what they ask for changes over time. Even if they're rereading what was stated, that information and those ideas evolve. And there's something out there called tacit knowledge. That's really information that's hard to communicate in any form of written or verbal form. These things make it very, very challenging to build software today. I think I have it up here. That's not what I meant paradigm. We write something down. We think we understand a requirement. We go build it, and your stakeholders or your market say that's not what I meant. All these things add to that depreciation of software, depreciation of features, and they pose challenges for us in the industry. So continuing on with that, the human factors and fallacies, we have to talk about some of the statements that we hear in the industry on a regular basis that make it challenging to bring Agile techniques into an organization, and we're going to talk about these. So the first statement I hear a lot from more traditionalists is we can build a highly accurate plan. Flat out, we know this to be false. In 99% of the cases, we know a highly accurate plan is not going to happen, and that's due to a couple things. One is the cost required to get close to being 100% accurate is astronomical. Very, very high cost to build something close to an accurate plan, but it's still not going to be perfect. We know that all these transforming of ideas and depreciation of value, all these things are going to add into our ability to build a highly accurate plan. There's been quite a bit of research over the last 50 years on something called time perception. These are psychology research projects and studies that have gone on, and task complexity. Ironically, the more complex the task, the more we underestimate the time it's going to take to get things done. So we're fighting these things, and what I'm sure all of you on the call here today understand implicitly is that we're really bad at this. And the cone of uncertainty has really been around for a long time. It shows us the variance of estimates, and it shows us how bad we actually are. We don't actually know when we're going to deliver software until we actually do so at the end, at the delivery date. At the beginning, when we first start talking, our estimates can be as much as 4 times off, and it's a problem, another problem that we're facing with traditional techniques and plan-based systems. Here's another one that I hear a lot of. I was hired to write code, and this would be a software developer speaking. Does code by itself have any value to the business? Again, assuming that your business is not in the business of writing code or showing code snippets. If you're producing a product that's based on software, or you're an IT organization that's building software to improve efficiencies, your job is really to make that software work as well as it possibly can, and to help the business actually make money either through savings or increases in revenue. What's challenging to this mentality too is commoditization and globalization. So if I know exactly as an organization what I want built, and I don't want to refine that at all, I've got a set of requirements. I can send that to Eastern Europe. I can send that to South America. I can send that to Asia somewhere and have that product built very quickly if all I care about is the product. So anywhere we have a group of developers that think that their job is just to write code, we're faced with the commoditization, globalization, as well as, which I don't even have on this slide, the fact that we're not taking into account things like quality and what the software is actually supposed to do. We just need better requirements, i.e. the more time we spend on refining our requirements and analyzing requirements, the better off we're going to be. It's blatantly false. There's a point of diminishing return. And good requirements come from a strong understanding of the market or the business. These things change. We know that businesses change over time. Again, people's idea of what they're asking for is going to continue to evolve, which is going to make the requirements outdated as we move forward in time. And writing the requirements themselves take time. So if we think about the idea of a system of events or a chain of events, from an idea to communicating the requirement to writing the requirement to getting the requirement actually implemented to actually being able to see in a piece of software what that idea looks like can take a lot of time. So we're challenged by that, and often writing longer, better requirements does not produce any better results. And there's a lot of case studies out there that actually show that. More upfront design will improve our quality. Again, the human factors that we've talked about already complicate this. Tacit knowledge, changing ideas, evolving ideas. And the fact that we don't have all of the knowledge and information on day one to actually implement the design correctly. And again, 99% of the cases this is true. The design that we come up with on day one will evolve. We know this to be true. Doesn't account for any change that comes in. Somebody asks for a feature change that we didn't account for in this design. Does it break the design? Does it break the architecture? Have we thought about being able to refactor and evolve the design when we do more upfront design? Law of diminishing returns obviously plays a factor. There's a point at which you can design the things away, but until you actually get the software working, you're unsure if the design actually is going to play out and be correct. And finally, how do you measure quality with this? How do you, with the design, how do you know if you've actually produced a quality design when it's just a meta definition of software? There's really nothing to look at here. And how do you know if the design that you're building is going to be quality in the end? There's no way to actually do that by spending more money on an upfront design process. Similar to the my job is to write code. To be effective, I should maximize the amount of code I write. You can replace maximize the amount of code I write with maximize the amount of bugs I find, maximize the size of the architecture I produce, maximize the amount of requirements that I write. We think about all of the traditional systems or traditional techniques that are out there, all the roles, just maximizing what they do, producing a lot of quantity of things. System thinking, theory of constraints, and a lot of the experimental work that's happened and case studies that have happened over the last 30 years show this to be false. Optimization and maximization of the system is the key. Again, going from idea to production as fast as we can, single piece flow, maximizing that is the best way of doing this. 30 years ago, Dr. Elihu M. Goldratt wrote The Goal, and for anybody that hasn't read that, it's an excellent book that talks about system thinking. The point of the book really is our job is not to manufacture any one piece. Our goal is to actually produce the software, that's the product, that can be used by the end customer and again can be used for efficiencies internally or to increase revenue. That's all of our jobs, and we need to think about maximizing the product that we build. Finally, quality is delayed to a later phase. That can lead to problems, which we'll talk about in a later slide. And then throughput. We've already kind of talked about that. From the idea to production, how quickly are we able to do that? And are those ideas actually making us money or saving us time? That's what we need to maximize, not the amount of code that's being written. Finding bugs is QA's problem. The one I'm going to talk about here is the two bolded items. So time to fix a bug increases over time, and we know this to be true, that the cost also increases over time. Lots of different studies out there that show, depending upon the software, depending upon the vertical that you're in, you know, within a few weeks, cost can go up 2 times. Within you know, a month or so, it can go up 4 times, 10 times, differing numbers. But we know that there's essentially exponential growth of cost as it relates to bug fixing. So we're going to use this fact when we do our case study at the end here today. That the longer we wait to fix bugs, the more it costs us. The final bullet there too is lean. There's testing at the point of work. If we test and make sure that what we're producing is quality and bug-free, we can ensure that it's going to cost us less, but it'll also allow us additional time to produce more software, more features that have more value, and can make us more money. So these two things play off of one another. We're spending less time fixing bugs. We're adding more value by spending more time focusing on features that have value. And again, we're going to use those 2 points in the case study coming up. Any questions so far?
It looks like there are no questions just yet, so you can continue, Chad. Thanks.
Feel free to ask questions, everybody. I mean, this is normally when I do this, I'm doing this in person, and I like to have a discussion. So if there's anything that you're kind of puzzled about or anything that you want to know a little bit more about, please feel free to jump in. So I talked about, you know, finance including a piece of risk and how we manage risk. So when we're talking about bugs, we're talking about risk in general, there's things like highly complex features that we don't know how to do that can introduce risk. But on most projects that I've worked on and most environments that I've been in, most of the risks actually come from quality. And the quality are coming in forms of bugs. And like I said earlier, we know that this grows exponentially. Now, I blogged earlier in the year about this concept, and we don't have pure unlimited exponential growth. We know that at some point we flatline the amount of time it's going to take to fix bugs, or we abandon fixing them, so we cap it off. So that exponential growth hits a certain point, turns to the right, and kind of plateaus. But for purposes of the discussion, we can say that we have a curve similar to the one on the right here. We don't want to be up on the high side of the curve or to the right side of the curve. We want to stay down early and find bugs as quick as we possibly can to keep the cost as low as possible. So we're talking minutes, hours, and at most days to find a bug. So that's surprising to a lot of people that, you know, hours to find a bug. How could we possibly do that? We cover some of this in the Scrum.org Professional Scrum Developer course that we offer. We also have a number of Agile testing workshops that we give. But again, we go back to this concept of testing at the point of work. So the moment I write a piece of code, a few lines of code, I should be able to test that from beginning to end with unit tests, integration tests, functional tests, and then be able to regression test the whole product. Very important to the overall success of building an Agile product, or a product in an Agile environment, I should say. The third bullet there, iterations allow us to reset our risks. So what we do is we're fixing bugs, we're making sure that we're managing them on a regular basis during the sprint. At the end of the sprint, we say, what do we have? Do we have any outstanding bugs? Do we have any features that are important? Are there things that we need to address? And we can do that every sprint. So we end up with a pattern that looks like the bottom left there, where we're constantly bringing that risk to zero because we're addressing it every 1 to 4 weeks. The bug count should be low when we start out. If the bug count is allowed to get high, by the second sprint, we should be attacking those bugs. We should be fixing those bugs and making sure that we don't allow them to move on. So we bring our risk back down to close to zero. So that's how we look at managing risk, managing quality, managing bugs, is fixing as quickly as we can and not letting them get out into the wild. I'm not even going to talk about things like the fact that bugs actually breed more bugs, and there's a lot of things that actually add to this exponential growth that we're not going to cover here today. If you're interested, reach out to me. I can point you to some other webcasts. I can point you to some other information that talk about managing risk in an Agile environment. Revenue value curve. So in the graph on the lower right there, we have a traditional or typical value curve. And if you think about how you would develop a traditional project where you're given a lump of requirements and you have to go work on them, we all know that the things that we'd work on initially usually are what we call, quote unquote, the low-hanging fruit. And so we may be working on things that have very, very little value to our customers, but since they're easy for us to implement, we do them out of the gate. And what we end up with, if we look at value over time on a traditional development process, is we end up with something that's a bell curve or close to a bell curve because of the fact that we're working on low value and high value requirements together. In an Agile environment or on an Agile project, we focus on only the things that provide high value out of the gate. So we quickly grow value, and we get to a certain point. We have a product that has the features in it, maybe a minimally viable product, something that doesn't have all 4,000 of the requirements that we initially envisioned. Maybe it's only got 40 requirements. But we realize as an organization that those 40 requirements or those 40 features are all we really need. So at that point, you know, the first dot there, let me see if I can highlight it for you. This dot right here, we can make a choice whether we want to continue with development or not. And from there you can see a bunch of different things. We can be done with that project, done with that product, release it, and we'll see a little bit of decay in value over time. We can continue to develop on it. So we would have something that looks like this, where we continue to add value, and at some point we're gonna start not adding a ton of value because the features that we're adding are balanced with cost, right? Value versus cost is going to be challenging, and we're going to get to this second point. We're going to get to this point where we're not seeing the return on investment that we'd like, and we stop developing, and we could see the value decay, or a product be continually used for years, and we end up with more of a straight line with a decay probably out over time. So again, this is important to note that by focusing on those high value things first, we can achieve higher revenue and efficiencies a lot quicker. I often hear people say that we develop faster with Agile. And what we're going to see in the case study is that's actually not the case. Most teams that I've worked with actually develop slower. And I get a lot of chuckles and questions about that when I say that. But what I mean by that is by focusing on high-value things and making sure we're testing it, we're developing slower, but we're delivering things that mean a lot to the market and to customers, and we're eliminating those, in a lot of cases, 80% of requirements that are meaningless. And so the perception is we're getting all of these very, very powerful features very, very quickly, and we're developing faster. It's an illusion. So we'll talk about that a little bit later on as we hit the case study. Any questions on this?
No questions yet at this time.
All right, thank you. So if we start bringing this all together and we look at longer cycle traditional or iterative techniques versus shorter cycle Agile techniques, we can compare those over time. Obviously, the business in a lot of cases just wants something to work. It wants a product that can solve a problem, and they expect that to have a target value. They expect a certain number of features to be realized to realize the efficiencies or revenue, and they kind of know from a stakeholder standpoint what that level is. This could be a revenue dollars. This could be cost savings from a time standpoint, and a number of features needed to actually get us there are usually kind of understood. But there's this gray line or red line in this case of what the expectation from the business is. In a traditional project, we would go some duration, let's just say a year, 6 months, and we would release version 1.0. I'm sure most people on the call have done this. Usually fall a little bit short of what the expectations are. We get it out there and people say, well, yeah, that's pretty much what I wanted, but we're missing feature A, feature B, feature C. Again, going back to that tacit knowledge, going back to that evolving ideas, evolving problem, evolving solution, all those things challenge our perception of what that first release is going to do. So typically we have a gap between that expectation and what's actually produced. I'm sure most of you have actually been on projects where there's a gap analysis done, and that's to actually close that margin. This area right in here, we do a gap analysis to figure out what we missed. So we go back and we do another iteration, and since we're fighting depreciation, we see that devaluing, and we actually have our gap features shown right here. That would approximately close this gap right here. But since we're fighting depreciation, we have a larger gap now. So we would do another gap analysis. And I could actually make this a little bit taller here. But what you actually will see is that you end up with a downward sloping line over time with a traditional project. Because we're fighting that depreciation, tacit knowledge, evolving ideas, utility, all of those things that we've talked about, we end up with something like this. So most organizations out here will say something like, you know what, we really missed it. Let's just throw this piece of software away, this 1.0 version, and let's release 2.0. And so you do a gap analysis here, maybe you add some new things, and this process repeats. I'm sure there's some implicit understanding out there as I'm showing this that this is actually true. You've probably all lived this. So Agile, on the other hand, or short cycle development. We come out of the gate fast and we deliver, let's just say, half the expected target value that we really want to get to. But we're getting some feedback. We're still fighting the same depreciation curve. We're talking about what we actually want to build here. We're doing gap analysis on an ongoing basis. What are we missing? What is it going to take for us to get, oops, go back here. What is it going to take for us to get from here to here? We're constantly discussing that with the business. And as we move forward in time, we're letting our ideas and that gap analysis move with us. So we add a little bit of functionality. We're still fighting the same depreciation curve we're fighting in a traditional project. We're releasing a little bit more functionality fast. Fight the depreciation, release a little bit more functionality fast. And as you can see here, the area under the curve between a traditional project and a short cycle or agile project is dramatic. The value produced is much more on a short cycle agile project than on a long cycle project. And this graph by itself can be used as a discussion point with many stakeholders to show why people are moving to agile. This is why it works. Take out all the other pieces, this is why it works. We also see another interesting piece here is that at this point we actually stop developing the software. So in about half the time that you've actually, on this graph, we've stopped developing and we let the actual depreciation occur, but we still produced more value over the same amount of time. So we're going to use this fact as we dive into the case study here shortly. Two other slides we're going to cover here that just talk a little bit more about the different models, finance and risk models. I often get asked the question about establishing a budget. How do I actually budget for a year, 18 months using Agile techniques? Because I'm not doing heavy upfront design, I'm not doing heavy upfront planning. So how do I do this? Is it impossible? No, it's just different. Traditional techniques, you'd actually perform a bunch of upfront analysis, you'd do time estimates, you'd look at doing things to breaking them down into a Gantt chart, looking at what your critical path is, trying to draw things back, figuring out where you actually want to release and working backwards. You guys have all done these types of techniques if you've worked on a waterfall project or a traditional project. Factoring in resource costs and then looking at your overall cost for the project. In Agile, we take a little bit different approach. We do lightweight planning. We may spend a little bit of time talking about it, maybe a couple of days. There's probably the same process ahead of this that's actually happening from a portfolio management standpoint. What type of things do we actually want to work on? What things do we find valuable from a business standpoint? But in place of doing heavyweight estimates and design, we're actually going to begin developing. So we establish a team velocity when we do that, and we now understand how many people we have working to give us that velocity, so we can now have a cost of that team. From there, we can extrapolate a budget. If we think that to get to all of the features that we're going to need is going to take us, let's just say high level 18 months based on the number of features we're delivering each sprint for a few sprints, we can say, we've got a $2 million budget for 18 months, and we're going to continue to manage that on an active basis. What's interesting is that a lot of finance departments out there actually like this model because it saves cost up front, and it actually allows more collaboration and communication with them and budgets to be actively managed versus, well, we don't really know where we are right now, or we do know where we are and we're over budget, over time, we need more money, that kind of stuff. The finance department's usually only cutting a check once a quarter, once every 6 months. Even though you have an 18-month budget or a 12-month budget, finance is typically not funding that budget in one lump sum. It's usually done on a quarterly basis. Agile fits in really well to that, allows a lot more communication, and allows you to bind better with that finance department. But there's some education to a lot of CFOs and controllers as far as how this actually works and why it works. A lot of them struggle with it, but as they begin to understand where this is coming from and what the makeup is, I've had a lot of people actually really, really enjoy this from a finance standpoint. Risk mitigation. Traditional approach would be tackle the long-term risks first. Say we've got something in 2 years, 18 months, even a year that we think is going to be very, very risky. Let's cover that, or let's actually attack that first, even if it doesn't provide a huge amount of value, and spend a sizable amount of time actually building risk mitigation plans. If we see this happen, what are we going to do about it? What's our plan A, plan B, plan C? In Agile, we actually deal with a lot of those risks as we move forward. We look forward to some planning horizon. We mitigate risks short-term to mid-term by actually just dealing with them and using things called spikes. And we also mitigate risk using time boxes, i.e., I'm only going to spend a certain amount of time on this, so I'm capping my cost. And I'm getting increased learning in that time box. Again, these two slides, a lot more depth in other workshops and presentations that we do. I just wanted to bring it up that they're important pieces to actually understanding how this all fits together. The final piece in risk mitigation here is working product. If you think about traditional techniques, a lot of organizations have to do risk mitigation or have to think about risk mitigation because we go from day 1 to day 600 without actually seeing working software. And so there's a lot of things that need to happen to make sure that when you get to, or that we think needs to happen, so that when we get to day 600 we actually have working software. In Agile, when we constantly have working software, we actually don't need to manage risk in the same way because we always know where we are. We always know that we have working software. We can choose at any point to change direction, pick a different plan, move in a different direction based on what we're seeing in the current working product. All right. Any questions? Those are the basics that we're going to use in this case study to kind of compare a traditional project versus an Agile project.
Okay, it looks like we do have one question here for you, Chad.
Okay.
So I can just read it verbatim here. So how does one mitigate long-term risks in Scrum, i.e. approach items which do not provide a lot of value otherwise and would hence only later be tackled from a sprint planning point of view?
So if I understand the question correctly, it's how do I mitigate long-term risk in a nutshell? Is that correct?
Yes, it is.
Okay. So long-term risk is typically only brought about when you're dealing with long-term projects, right? So long-term risk would be I have a long duration, I have a long payout that I have to deal with from a finance model, 18 months, 2 years, 3 years. I need to manage risk so when I get down that path, I'm not boxed into a corner. It's basically trying to deal with what happens when things change. What happens when the market changes? What happens when something that I expect from a software standpoint doesn't work the way I expected it to? I need a risk mitigation strategy. In Agile, we're moving and understanding that on a real-time basis, and we're constantly looking forward, constantly thinking about what the product is, what it could be, and looking out long-term, mid-term, short-term. The difference being that we're not spending a ton of time actually addressing those things if they don't feel viable. Does that make sense?
So yeah, it looks like that was definitely helpful, Chad. Thank you for that.
Sure. If there's more questions or you want to dig into more depth on that topic, please feel free to reach out to me after the presentation here.
Absolutely, and we're probably going to start wrapping it up within 5 minutes or so, just so you know.
Great. So I'm going to whip through this based on what we've already talked about and let you guys ask any questions at the end. So we want to develop an application called mugshot.com. Similar to Facebook, not really important to the case study. We're just going to develop this application. What we know, here's a list of requirements. Come back and actually take a look at this after the presentation, rewatch the webcast. 120 requirements, 6 developers. Each software engineer generates 4 bugs a day. Each bug will take 15 minutes to fix, and that'll increase over time. First week we go to 30 minutes. After that we go to 90 minutes, or up to the first month. We go to 90 minutes after the first month. 2 changes per week, right? So things change, requirements change. We're going to see 2 changes a week. Those are the important points for this case study. So our traditional approach, we do some estimation, do discovery phase. We have to get some budget approval to make sure that we're on par. Build some architecture and design. Very conservative here. I'm saying that to go from estimation all the way through design is only going to take us 4 weeks. I think this is probably a little bit low, but I wanted to be as optimistic as possible here. Based on our team size, it's going to cost us $48,000. Implementation, we estimate that it's going to take us, we're going to be able to do 10 requirements a week, 12 weeks to actually get this done, to get through all of our requirements. We remove the cost of the QA resource because we're not including QA in this. Testing comes later. So we only have a weekly burn of $10,000. That gives us $120,000 to implement this in a traditional technique. Now we actually have to fix all the bugs. So we bring the QA resource back in, software engineers back in. We go with the fact that takes more time the longer we wait on bugs to fix them. We have some durations here, breakdown. Essentially, it costs us $330,000 to fix bugs at this point. Total summary, start to finish, to produce the software, $498,000. There's some notes down at the bottom I encourage you to come back and look at. We generate some waste in here. We also could be off on this. It could cost us $250K all the way up to close to $1 million based on our understanding of the estimates. From an Agile standpoint, we sprint. Out of the gate, we do our first sprint. We're continually managing risk, continually doing architecture and design, but instead of doing 10 requirements a week, since we're testing and we're managing architecture, we're only getting 5 requirements a week done. Oops, we have bugs in our code. We have to fix things. So half the amount of features per week. Sprint 1, 2 weeks, cost us $24,000. So for then on, we're constantly managing risk, fixing bugs, listening to our clients, managing the new change that comes in. Since we don't need to implement 20% of the requirements, it means we only have 96 initial requirements. So again, go back to look at the detail to see why I say that. And only 1.6 new requirements a week. Those are the things that actually make it into the product. This is what it looks like. By adding the new features and continually delivering features, we see that we cross 0, or we actually deliver the product at 20 weeks. Even with the new requirements coming in and the changes that we see coming in, we're managing those at every one of those lines. So an Agile summary, we did 10 sprints over 20 weeks. It cost us $240,000. Here's the comparison between the two. $500,000 versus about $250,000. We delivered what we thought we needed in a one lump sum in a traditional project. We depreciated the preference. We depreciated the value of the software by doing it that way. By managing it actively, we maximize the preferences. We maximize their value that the clients actually have for the software. We've also eliminated the waste by not building features that were unneeded. It took us about half the amount of time, and the bugs cost us about 1/3 of the amount of money to fix. This is it. This is where the rubber hits the road here, people. This is what we're seeing out there, about half the amount of money to do an Agile project and build software in an Agile fashion as compared to a traditional technique. Don Reinersten's book is worth reading, Principles of Product Development Flow. He talks about some of these concepts in there. It's worth reading, worth a look. Worth mentioning, a lot of these topics are going to be talked about. I'm going to be giving this presentation as well at ALM Chicago next month on the 22nd and 23rd in Chicago. For more information, go to almchicago.com as well as to register. Where do you start down this path? How do you get your hands on this and actually get more active with getting Agile brought into your organization? Go to scrum.org and start taking some courses. Centair offers all of the courses listed here, and we would be happy to talk to you about some of the topics we talked about today, as well as many, many, many others. And with that, I thank you.
Great. Thank you very much, Chad. And it looks like, if you don't mind, we have one more question here in the chat window.
Yep.
Okay, so I'll just read it here. So during an Agile project, if the client, the end user, does not take their time at each checkpoint of the development process, what should we do? Should we wait for the end user, or do we move on to the next stage?
So I would answer that that's not really an Agile problem. You're probably going to have the same issue in a traditional project, right? If you're not taking your time building requirements and looking at the software, inspecting it, you're going to have the same issue. So you really have a commitment and people problem, and we would address that differently. We would address that at the leadership level. We would address that at the team building level. So we'd have a different level of communication there. There's no silver bullet to make people commit to what they're doing. You actually have to get some enrollment, and you have to get the right teams built. I know a lot of people have tried to use Scrum and XP to get that pulled out, but unfortunately you've got a people and organizational issue, not a process problem.
Great, great. So it looks like we're about over our time box here, so I'd just like to wrap it up and say thank you very much, Chad, for joining us. It was great. And we'd also like to thank our attendees here for joining us on today's webcast. You can contact us at Webcast at scrum.org for any questions or comments or feedback that you have. And we're on Twitter. You can follow us at scrum.org. And you can learn more about these webcasts at scrum.org/webcast. We look forward to seeing you guys next time. Thanks.